Welcome back. We are talking about water and wastewater engineering concepts. And in this video, we'll talk about the population forecasting, why it is so important. When developing a water supply systems, we need to understand two things: how much water is to be supplied and for how much population. How much water supplied is based on the water demand, and how much amount of population is depends on the design period. So 30 years, 40 years. So how much population is expected by the end of that particular period? So in such a case, we need to understand the trends of population changes over the previous decades, and based on that, we need to find out the population at the end of a design period of a system. So that's why this is most important. So once we know the population at the end of the design period, so we multiply that population with the water demand, we'll get the total amount of water to be supplied. So the target for developing a water supply facility is that much of water to cater the needs of population at the end of the design period. That's why population forecasting is important. There are a number of methods where population can be forecasted based on existing data. So we'll look into those details in this video. So now let us look at in this scenario, water requirement estimation is how much population served multiplied by water demand. So the water demand is expressed in terms of LPCD. Let 1 lakh population is there at 200 LPCD water demand. When you multiply both, you are going to get around 20 MLD or 20,000 meter cube per day or 20,000 KLD. So the target will be 20,000 KLD for the population. So required or predict population at the end of design period. For water supply systems, around 20 to 40 years of design period we take. For reservoirs, 50 years. Pumping system, around 20 years we take. Let us quickly look at the factors affecting population growth. So in this, how the population will come to a particular place. There should be some employment opportunities for the people and what you call as economic factors. And there should be some development or future development where the people can come and invest, industrial options, in business opportunities. And there should be social facilities. What type of social facilities are there? Recreational, cultural, and then communication links. What type of communication links they're having? What type of tourism facilities are there where the people can come and stay there and then develop their living for their betterhood. And then the transport facilities where the place is connected to rail, road, or water, all such type of things you have to look at. Where, how far is the airport? What about the educational facilities? What about the hospital facilities? What about the other facilities which are there required for a complete life? And everything is available or not? And most importantly, the unforeseen aspects, that is prone to earthquakes, is prone to landslides, they're prone to cyclones. It's a safer zone, then people will come and they stay here, they will invest money, they will develop the facilities, then they keep on living, and then they improve their own economy, and then they develop the economy of the area. They purchase lands, they develop real estate, all such type of things will start happening. So that then only the population will immediately come and grow. So the population will increase. Otherwise, if any of these facilities are not there, then very less growth of population is expected in that area. So how to predict the population? Arithmetic increase, geometric increase, incremental increase, graphical extension, master plan, and decreasing rate of increase method. Let us look at one by one. The arithmetic increase method. This method assumes that the population is increasing at a fixed amount of increase per decade. So Pn is the population at the end of n decades is equal to initial population plus Average increase per decade of population into n is the number of decades. This is useful for very old cities where population is not expected to not changing much, but for a constant increases. Stabilized communities. Another one is geometric increase method. So this is particularly useful for the places where the population is expected to grow tremendously, and due to the sudden burst of facilities, the factors what we discussed earlier, they are suddenly found to be very high. Opportunities are more. Then we can see a sudden flux of population entering into that city with a geometric growth rate. So here they will calculate two different types of growth rates, arithmetic average method and the geometric average method. The growth rates for each decade, we are calculating I1, I2, I3, etc. And divided by n will give you the arithmetic average growth rate. And the same thing, the decadal growth rates we can calculate, and then we can also calculate the geometric average. And using that information, we use this formula to calculate the geometric increase method population. Pn is equal to P naught into 1 plus Ig by 100 all to the power of n, where n is the number of decades. Incremental increase. So there will be some period where the population will be increasing per decade. There will be some period where the population decreases in a particular decades. So the net value also we have to take to find out the incremental increase in the population. So combining that, we are having Pn is equal to P naught plus n into I, as n into n plus 1 by 2 into R, where the I is the average decadal increase and where R is average decadal incremental growth. That is, it can be positive or it can be negative. The net value only we are going to take it here. The illustrations will be taken through some examples in another video. And then we are having this graphical extension method. The graphical extension method is very simple to do it without any calculations. So we have the data of the population in the previous decades. We'll plot it with respect to years on the x-axis, population on the y-axis, and now you'll plot the population here, and then we'll extend, assuming that the trend is going to continue in a similar model, and then you'll find out the population here. For example, we have data up to 1991, and we want to 2011 we extend it, and correspondingly, whatever the population here on the y-axis, say 80, probably 80 in thousands, 80,000. We can simply come out with that design population is around 80,000. The data available up to a population of 1991, which is around 75,000. So only 5,000 is increased in the next 2 decades. This is how we are going to do it. The master plan method. Master plan is a more systematic way of calculating the population. The entire area is demarcated into different zones: residential zone, commercial zone, industrial zones, where the areas are coming. And for each area, the population density, you are going to allocate. The town planning office, they are going to do this job. How much of your density are going to provide in this commercial zone, in the residential zone, industrial zone, like that. So accordingly, they will give permissions to these places for development. Say, for example, apartments in the residential area, 200 to 2,500 per persons per hectare. This is the density, this is planned. Let us assume that in one particular area, 1,000 persons per hectare is developed, and with this ratio or density, 10 hectares of land is developed. The total population, which is coming out to be the area multiplied by population density, is coming out to be 10,000 population. So like that, if we know the population density, and then that particular area, we multiply these, and then we can come out with the overall population. This type of things sometimes may not be existing, and they may be planned also. Even then, we can plan this or predict the population based on the records available through the town planning office. That's why it is called as a master plan method. So these are some of the important methods which are available for estimation of a population for the design period. So illustration of these methods will take up through a different video with small examples. Okay, thank you.